Let's keep practicing this static equilibrium stuff, all right? Let's say that we have a diving board, okay? And we want to, obviously, you don't want someone on the edge of a diving board and then have the diving board just collapse. It's just a real bummer for the person on the board and for everyone that has to watch it. So what would be the forces required in the bolts that are holding in the diving board such that the diving board doesn't collapse, such that it's in static equilibrium? Well, let's take a look here. If you could go to the slide that says diving board dilemma, okay, we have a diving board that looks something like this. Okay, we have like a little piece that's holding it down here, and then we have like a bolt that's like it's resting on over here. Okay, and then you have a person over here. Okay, and so this distance here is about 1 meter, right? And then this distance here is about 2 meters. Okay, what else do we know? We know that the whole thing is 3 meters long, right? We know that the diving board itself weighs 280 newtons, right? And that's going to be applied right in the middle, right? So I'm going to use a different color for my forces. So that's going to be the weight of the board, okay? And that is, it says 280 newtons, okay? And we have this weight of the diver. I'm going to call this WD, the weight of the diver. And she weighs 500 newtons, right? And then the whole question is find the force of the support point and the force at the left-hand end so the diving board doesn't collapse. So this is the left-hand end, right? And you know, this is like, basically this is a normal force where this like little upper lip is pushing down. So I'm going to guess that that left-hand force, I'll call that force L, is pointing down here. And this is the support, right? So I'm going to go ahead and take a guess that this support is going to be a force that goes up, so it's F support, all right? There's a couple reasons why I guess that this must be pointing up. One is because it's resting on it, and if it's a normal force, then that should be pushing up on it, right? But second, I'm going to need some force in the upwards y that balances out all these other forces, okay? So that's a pretty good guess. But here's the thing. A lot of folks ask, what if I guess the wrong direction for any of these forces, right? And the truth of the matter is, it doesn't matter. Because in the end, if you pick the wrong direction, all that happens is you're going to get a negative answer. And if you get a negative answer, all that tells you is that you picked the wrong direction for a force, okay? So a negative answer for any of these forces that you calculate just means you picked the wrong direction and you just reverse the arrow. That's all, okay? I hope that helps. So step one of analyzing any static equilibrium problem is to draw a very good free body diagram. And I think that we did, right? This looks pretty good to me. Okay, I have, again, it's another problem where I have 4 forces. It's always helpful to remind ourselves, what are we actually looking for? We're looking for this Fs, the force of the support on the board, and this Fl, the force of this left-hand, I don't know, it's another support. They're just trying to find something to call it. Okay, so Fs, Fl is what we're looking for. The second step is to write your equations, okay, for static equilibrium. Remember, the first equation for static equilibrium is that the sum of forces in x must equal 0. Are there any forces in x? Again, I gave you a little kind of an easier one where we don't have to use that equation. No forces in x here, okay? Summation of forces in y must equal 0. Well, let's go ahead and do that. Sum of forces in y must equal 0. What's in positive y? Well, we have Fs. In negative y, we have minus Fl, minus 280, and minus 500. And they all must add up to 0. Okay? Cool. So again, we're in this situation where we have one equation and 2 unknowns. Where do you think we get the other equation from? Well, you can guess it's going to be summation of torques equals 0. Okay? Well, what are all the torques? Well, let's pick a rotation point. Again, why not just pick this one? That's really easy. It's a rotation point that already has a force acting on it, so we know that that torque is going to be 0, right? Because the distance r between that force and that point is 0, so it'll cancel out, okay? What are the other forces that are creating torques on this board around that point? Well, let's start with positive torques. What force would cause a positive torque? In other words, which force would cause this board to rotate counterclockwise? Well, Fs, right? That's the only one, really. So we would say that the distance, 1 meter, times Fs, right, times sine of 90, which, again, is 90 degrees, right? So that's just 1. Okay, minus the weight of the board, again, is going to be a negative torque because it's going to make this board want to rotate clockwise, okay, like the hand of a clock. All right, how far away is this? Well, the board is 3 meters. It's got to be acting at the center of mass, so that's got to be 1.5 meters, halfway in the middle of the board, okay? Times its weight, which is 280. All right, we're getting somewhere here. Lastly, we have another negative torque because the diver is going to want to make this board rotate clockwise. And so the diver is 3 meters out, right? And we can say that her weight is 500, and that must equal 0. All right. Look at this. We have this. We can just put this in a calculator. We have that. We can put that in a calculator. There's just a 1 in front of this. It makes it very easy to find the weight or the force on the support, which, according to my calculations here, is simply going to be 1920. 1,920 newtons. Okay? All right, we're halfway there. Last thing is we need to find out the force on the left-hand side here. Well, now that we have this, all we need to do is substitute it right into there, solve for FL, and ladies and gentlemen, for FL, I get 1,140 newtons. Okay? And there we go. There we solved it, right? So if I am an engineer designing this diving board, I know this support has to handle at least 1,140 newtons. The way it works, though, is in reality, you make sure it can support like 10 times that, so you're sure that anybody on this board can survive, right? And you want to make sure that this area of this board, or the material that the board is made out of, can support 1,920 newtons, okay? But again, really like 10 times that, so that anyone, no matter how heavy on this board, will be able to survive, and the board will be able to handle it. Yeah, so we're going to do one more example when we come back. And in that example, we're going to ask the question, what happens when the angles aren't so nice? And what happens when we have to deal with the sum of forces in X too?